Alright, so then we're going to go over how to map stoichiometry problems. So before that, we'll just do a quick review on how to convert between grams and moles, which you're going to need for the upcoming lessons. So let's say I have, I'll cancel that out. Let's say I have 2 moles of carbon, and I want to turn that into grams. Well, if we want to turn that into grams, you have to use the periodic table. We're going to go ahead and multiply this times a fraction like we always do. Moles of carbon, so if I want moles of carbon, go on the bottom. If I want grams, grams are going to go on top. Okay. Then we look at our periodic table. Our periodic table tells us the mass of 1 mole. So 1 mole of carbon equals, you can round that, 12. So 1 mole of carbon equals 12 grams. We do the math. This cancels. I'm left with 2 times 12 gives me 24 grams. Okay. All right. Let's say we're doing the opposite. Let's say I have 3 moles of, or rather, let's not go moles. Let's say I have 28 grams of nitrogen. Okay. And I want to convert that. And I want to convert that into moles. So I go times a fraction. Grams go on the bottom. That's what I'm starting with. Moles is what I want, so that goes on top. Now I'm doing moles of N2. Okay, so 1 mole of nitrogen equals 14 grams. So 1 mole, remember we always use 1 mole, that's what the periodic table tells us, equals 14 grams. So that gives me 28 times 1 divided by 14. Grams cancel, gives me 2 moles of nitrogen. Okay, so this is just review. So there's a video there on the website if you need to review this. Okay, let's go over how to map out problems. So what we're doing today is we're doing problems in which we have a mass of a product or of a reactant, and we're trying to go all the way to the mass of another substance. Okay. What that substance is, well, it depends. It depends on the problem. Okay. So, in other words, remember, mass is measured in grams. So we're going from grams to grams. However, this is not a one-step conversion. You can't just go from grams to grams. You have to follow a certain path. Okay. So first, let's map out the path, and then we'll go ahead and do some examples. So if we think about this as like you're traveling from one individual's house to another individual's house, you have to take a certain path, right? So let's say we have this street here, right? You start off with, you're at this house, you're starting off with grams of product A, whatever that is, okay? You want to end up at grams of the product or the reactant. We'll just name that B for now, right? Well, I can't go directly to this house because there's going to be some things that I got to do first. So first, when I have to go from grams to moles of A. That's the first thing I have to do. Well, to go from grams to moles, we should know how to do that already. We're going to go ahead and go through, let's say we have to go through this specific street. Well, what would that street be? How do we go from grams to moles? Well, we use molar mass, right? So let's just say this is molar mass avenue. All right, so we've traveled from here. We're going to here. Now, from moles of A, whatever we start with, we have to go to moles of the next thing. So let's say I want to go to moles of B, right? Well, what am I taking? What path am I taking? Well, whenever I go from moles to moles, we use the chemical equation. In other words, we use the what we call mole ratios. Okay, so we're going to go and travel through mole ratio avenue. Okay, we're going to travel through here. Finally, we're almost there. Well, now we're at moles, and then we're going back to grams. So again, we have to go through molar mass. Let's just name this molar mass boulevard. Okay, and then we can get there. So you have to go grams, moles, grams. You can't go directly from grams to grams. Okay. In other words, in short, if I'm mapping this out, I need to go grams of A to moles of A to moles of B, all the way to grams of B. Okay, so that's what we're doing today. We're going to be reading stoichiometry problems. Remember, stoichiometry is the math behind chemical equations, and you are going to be mapping out how we actually solve those. So you're not going to solve it, you're just going to map it out. Okay, let's look at some examples. So here's my first example. If you notice, we have it kind of mapped out for you. We have grams to moles to moles to grams. Okay, so let's read the first one. How many grams of NH3 are produced from 40 grams of H2? In other words, I have 40 grams of this, and I want to figure out how much grams of this can I make. Well, all we're doing today is mapping it out. So I'm starting with grams of H2. If I'm following this path, then I need to turn that into moles first. So then I will turn that into moles of H2. For moles of H2, I go to moles of whatever I'm looking for. Well, I'm looking for this, right? But I can't go to grams right away. So from this, I can convert it into, using the equation, we can convert it into moles of NH3. Then from there, I can turn it into grams, which is what I'm looking for. Grams of NH3. Okay, that's all you're doing today. You're just mapping it out. That would be your answer. Okay, let's look at another example. Next one. Still using that same equation. How many grams of N2, that's what we're looking for, are produced from 80 grams of H2? In other words, it shouldn't be produced, but rather react. So if I have 80 grams of this, how many grams of this do I need to react? Let's go ahead and follow the path. Well, I'm starting with grams of H2. If I want to figure out grams of this, I have to go through the pathway. I have to first turn these grams into moles. So from there, I would turn it into moles of H2. For moles of H2, I would go moles of whatever I want. Well, I want this, right? So I'd go moles of N2. Finally, I can convert these moles into grams. So then I would go ahead and turn that into grams of N2. Okay. All right, we're going to go ahead and go through. We're going to go ahead and go through another example. All right, so this example, same thing, we're just mapping them out. So it says, how many grams of oxygen are produced by the decomposition of 100 grams of potassium chloride. Okay, so this is potassium chloride. All right, so, well, we have 100 grams of this, so we're starting with grams of KClO3. Then we have to turn that into moles of KClO3. Finally, into moles of what we want, which is oxygen. Then into grams of oxygen. That would be our final answer. Okay. Okay, let's go over these last two mapping problems. So this one's asking us, how many grams of AgCl, silver chloride, are produced from 25 grams of AgNO3, okay, silver nitrate? So again, we're just mapping it out. So we're starting with grams of AgNO3 but we want grams of AgCl. So from here, we would go to moles of AgNO3. Then we can go to moles of what we want, which is AgCl. Then finally, we can turn those moles into grams of AgCl. Okay. Let's do the last one, which is slightly different. So this problem is asking us, so it says, if you start with this many grams of this carbon-hydrogen compound, how many grams or how many moles of H2 can be made? So this is different because we're going from grams to moles of this. We're not going all the way to grams. We're stopping at moles. Okay, so same process though. We start with grams of C3H8. We first turn that into moles. Okay, then we can turn this into moles of what we want, right? Moles of H2O. Well, this problem was asking us for moles of H2O, so we just stop here, and then that would be your final answer. We wouldn't have to turn this into grams. We can just stop here because this problem is asking for moles, it's not asking for grams. So you might see a few problems like this. Okay.